All right, good afternoon, Algebra 2. We are going to do lesson 69. And there's lots of parts to it, but it's not difficult. They just put a lot in this section, so hang tight with me. So I'm going to do some examples, and then we'll jump to lesson practice and back to examples. So first, let's talk about graphing complex numbers. Now, I know that sounds hard, but it's the easiest graphing you'll ever do. So when we graph, the y-axis is the I-axis, and that should be easy enough to remember. Instead of y, it's I. The x-axis or real axis is one and the same, so real and x. So here's my real, and so let's say I have 2. You would label it the same, so 2, 4, and on the left is -2 and -4. And on the I-axis, it would be like this is 1i, this is 2i, 3i, 4i, and so on above. Below, -1i, -2i, -3i, -4i. All right, so let's practice graphing. So I'm going to graph the following. So number 1, we're going to graph 3 plus 4i. So really simple. You're going to, and I should have done this in another color so we can actually see it on the graph. So +3 on the real axis, so +3, and then that's a +4i, so positive. So there is number 1. All right, number 2. Graph -2 minus 3i. So -2 is on the real axis, so -2, and then down to 3i. So there is number 2. We'll do one more. We'll do 2i. So notice here, I don't have a real part. So I'm going to start at the origin, but I have a +2i. And so there is number 3. So I hope that helps. It's pretty simple. And that's it for graphing complex numbers. I did it on the same axes so that we don't have to keep drawing it. So let's now go to our lesson practice, which is on page, hold on, sorry, I don't have the page turned to it. It is on page 492. And so let's do A, B, C, and D, and we'll do it on the same axes for just to keep it short and sweet. So here is so when you graph, make sure the y is I, and this is our real. So 2, 4. This would be 2i, 4i, -4, -2i, -4i. So here are the 4 they'd like us to graph. In part A, they want us to graph 1 minus 3i. In part B, they want us to graph -2 plus 4i. In C, -3. And D, 2i. All right, so I'm going to graph each one. So A would be +1 and down 3i, so there's A. Sorry about that. B is -2 and +4i, so there's B. C is -3 and there's no imaginary, so there's C. And D is +2i. And that's it, guys. That's it for graphing complex expressions. So that is the first part of this lesson, okay? We're moving on to part, and I'm actually going to fold this under to make room. So part 2, we are going to do finding the absolute value of complex numbers. So absolute value, review, is our straight bars. And they've given us a formula. The absolute value is the square root of the real part squared plus the imaginary part squared. So I'm going to do one with you. Well, I'll do two with you, and then we'll do the lesson practice. So what number are we on? We are on, I'm going to start with number 1. So find the absolute value of -3 plus 5i. So the formula is, let's identify a. So a is -3 and 5 is b. So I have -3 squared plus 5 squared. And that's that. So 3 squared is 9 plus 25. I get the square root of 34. And the 34 doesn't have anything I can simplify, so that's it. So number 2, let's find the absolute value of -2i. So in this case, notice I don't have a real. The real would be a. So since I only have the imaginary part, this is b. So I have -2 squared, which equals the square root of 4. So our answer is just 2. So for this one is 2. The last one was the square root of 34. So let's go back to our lesson practice, page 492. And now let's attempt part E, F, and G. So part E, they would like the absolute value of 7 minus 2i. So here's A, here's B. So the square root of 7 squared plus the -2 squared. Right, that gives me 49 plus 4, which is the square root of 53. And I believe 53 is a prime number. Now notice that -2 squared became a positive. Every number squared becomes a positive because a negative times a negative. Okay, so be really, really careful on those. I'm going to go ahead and turn the page, and we will do, I guess I can do F right here. Never mind. -5 plus I. All right, so let's talk about this one. A is -5. There is an invisible 1 here, and that is B. Okay, so I have the square root of -5 squared plus 1 squared. That's 25 plus 1, so the square root of 26. Okay. One more before we move on to there are 2 other parts to this section. And so G, they'd like the absolute value of 10i. So again, all I have is 10 squared, which is square root of 100, which is 10. All right, moving on to the second part, or third part of our notes. So we did how to graph them, how to find the absolute value. Now we are going to multiply complex numbers. And I need to go over I, remember, equals the square root of -1. So I squared would equal the square root of -1 times the square root of -1, right? Because you have I times I, which would equal -1. So whenever we see I squared, we're going to we're going to replace it with a -1. So this is really important. Okay? So here we go on multiplying. -4i times 7 plus 3i. So I'm simply going to distribute, and I get -28i minus 12i squared. Now I'm going to replace, right? I know that I squared equals -1. So I technically have -28i minus 12 times -1. So I have -28i plus 12, because the -1 changes the -12 to positive. Now when we write our answers, the real part must go first. So my final answer is 12 minus 28i. It's a positive 12, because that's a plus sign, and then a minus 28i. So we want to make sure we write our answers properly. So let's try one more, a little bit more complicated of one. If I have 5 plus 4i times 6 minus 2i. So again, we're going to distribute. 5 times 6 is 30. 5 times a negative 2i, multiply it just like you would x. So 5 times 2x would be 10x. But in this case, a positive times a negative is negative 10i. 4i times 6 is 24i. And 4i times negative 2i. 4 times negative 2 is 8. I times I is I squared. All right, so again, we're going to replace that I squared with a negative 1, changing this 8 to a positive 8. So let's write our answer. Let's do the real parts first. So 30 plus 8 is 38. And then combine your imaginary and you get positive 14i. So let's go back to lesson practice, part H. So part H asked us to multiply 8i times negative 9 minus 5i. So if you distribute, I get negative 72i minus 40i squared. Now the I squared is a negative 1, changing this to a positive 40. So my answer is 40 minus 72i. Let's try part I from lesson practice. So it was 2 minus 3i times 5 plus 9i. That would give me 10 plus 18i minus 15i minus 27i squared, right? Then I times I is where I'm getting I squared. Now I know an I squared is a negative 1, which means this is now positive 27 because a negative 27 times a negative 1. And so I'm going to combine the real. 10 plus 27 is 37. 18i minus 15i is 3i. So 37 plus 3i. All right, last part, and I'm going to do it different from the book. I'm going to do it in a simpler way that I was taught, simplifying. So, I know that I squared equals negative 1, and I know that I equals the square root of negative 1. And I don't even think you need all of that. You don't even need this part of the information. So let's simplify the following. So let's say I have I to the 30th. I to the 30th is, in order to simplify this, I'm going to simplify my term in terms of in terms of I squared. So I to the 30th would be I squared to the 15th power. There'd be 15 of them, which I know I squared equals negative 1. So negative 1 to the 15th power, if you enter that in your calculator, any odd power will give you the negative answer. So I to the 30th is just negative 1. Let's try one more before we do the lesson practice. So 5i to the 9th. I'm going to replace I to the 9th and write it in terms of I squared. So I squared goes into I to the 9th 4 times, right? Because 2 times 4 is 8. But I would have one single I left over, right? 2 times 4 is 8. 8 plus I to the 1st is 9. So I'm going to rewrite this. This is 5 times negative 1 to the 4th times I, which equals 5i, because negative 1 to the 4th is a positive 1. So let's go back to our lesson practice. We are now on page J, or part J. They want us to simplify I to the 18th. So let's write this in terms of I squared. So 2 times what would give you 18? 2 times 9. Then replace I squared with negative 1, and negative 1 to the 9th, and 9 is odd, so it's negative 1. or use your calculator, but make sure you use the parentheses. K, they'd like us to simplify negative 3 times I to the 11th. So negative 3, then let's write this in terms of I squared. Well, 2 times 5 is 10, right? That would give me I to the 10th. So then I need this I here because that would be I to the 11th. So that is why I have I squared to the 5th, but then I have an extra I because 10 plus 1 is the original 11. So now I'm going to simplify negative 3 times negative 1 to the 5th times I would give me negative 3 times negative 1 times I, which is positive 3I. Now we have a couple more, and then we have one more part to this lesson. So L, they'd like us to simplify 1/2 I to the 21st. So that would be 1/2 times I squared to the 10th. 2 times 10 is 20 times 1 extra I. So that'd be 1/2 times negative 1 to the 10th times I. That'd give me 1/2 I. So hopefully you see a pattern in even and odd numbers. All right, whew. Last part of our notes is dividing complex numbers. So to get rid of I in the denominator, we have to eliminate any I that's in the denominator. So for example, and we're just going to do the lesson practice to keep it short and sweet. In part M, it says divide 3 plus 3I by 3I. So in order to eliminate, because there is no sum or difference in the bottom, I'm simply going to multiply top and bottom by I, just like we would to get rid of a square root. And so I'm going to distribute, so 3I plus 3I squared divided by 3I times I is again 3I squared. Now I'm going to replace these with negative ones, and so I get 3I minus 3 over negative 3. And then we're going to write this in proper form. So I'm going to write the real part first. Negative 3 over negative 3 plus 3I over negative 3. So that gives me 1 minus I, right? A negative divided by a negative is a positive 1. A positive divided by a negative is a negative 1. So a negative 1I. Last one. Divide negative 4 by 2 plus I root 3. They put all kinds of fun stuff in here. So for me to get rid of, we're going to multiply by the conjugate, just like you would with the square root. So we're going to multiply by 2 minus I root 3. And then I will distribute. So that gives me negative 8 plus 4I root 3 over 4 minus 2I root 3 plus 2I root 3 minus I squared times 3. So I'm going to replace this I squared with a negative 1, and these cancel. So my final answer is negative 8 plus 4I root 3. This becomes positive 3, so all over 7. Phew! And that is all the parts of this lesson.